first off, just to square away for everyone here and in the future, if they watch this as a recording, I'm going to just orient ourselves around the PCNSE page and the study guide. So just let me share that out here. All right, and I'll get a nod from you guys if that actually worked correctly. Awesome. So much like we reviewed on the intro session, there's a landing page from Palo Alto that really highlights a number of resources. We went through that in the first session. If you keep scrolling down on that page, that I can just dump in the chat as well, there is a section called Study Guide. And that is what we're going to use as we sort of go around our table and dig into some of those exam domains. I'm going to go to the study guide. I'll also just copy a quick link in there as well in the chat. Excellent. So getting ready to dig in, I wanted to, what we sort of had as a bit of a takeaway between the team. Unfortunately, Mohammed's not here with us for this session. So between the rest of us here, we will work to cover that one on his behalf. Before we dig into the first domain, I did want to highlight one aspect just from a high level to give some context. Sort of fumble and scroll to that point. It was this right here. So on page 10, they actually outline the weighting of each of these domains on the overall exam. So what we're going through today is really 12% of the overall exam. And I thought that was just another good piece from a high level for us to just digest before we go through those specific domains. All right, into domain 1. So internally, the core concepts, when we digested this ourselves, it was really tough in a way because there's a lot of really high level aspects in domain 1. It's sort of level setting, some product awareness, and things of that nature. So what I want to do is, I don't want to read this out now. I sort of want to reflect some distillations that help me share that. I encourage, as I go through this, to the rest of the team, jump in with any questions. But really, overall, you'll see a reference to a name called Prisma in this guide. You'll see a reference to Strata in this guide, and you'll see a reference to Cortex in this guide. And I really wanted to hit home that from a product organization from Palo Alto, they have divided all of their products fundamentally into these 3 domains. And this domain, this certification is about the Strata domain. The Strata domain is where the next generation firewall fits in the greater Palo Alto ecosystem. That is good to know from a high level wherewithal, just from a naming perspective. I think from an exam preparation perspectives, we should just understand what those domains, Strata, Cortex, and Prisma are and are not, just from just a high level description. And then understand where we go from a depth perspective is Strata, or the firewall, next generation firewall. From there, sort of double clicking down into the Strata domain, they really want you to get a concept of the firewall can be offered in physical form factor or VM series. And it's the same fundamental firewall running PAN-OS, just in different form factors. And they seem to dig, so I'm going to skip by some of those names here. Like I said, Prisma, Cortex, this is sort of product family familiarization. They then get into talking about firewall components. And for someone who likes things to be sort of methodical and thorough, What they did here, my take is they cherry picked some foundational elements out of the firewall from a base understanding. It's not comprehensive, but everything in this section, sort of 112 and beyond, you're going to double click and get into deeper throughout the rest of the exam study guide. And it seems like the intent here is to sort of have some basic familiarity on these firewall components, which you dig into deeper as time goes on. So security zones, for people who have had experience with other firewalls, it's just a zone construct. This is a zone-based firewall. Zones are always attached to logical interfaces. Zones are always referenced in the security policy. Traffic comes in and out of interfaces, goes through security policy. We're really trying to hit that down from a fundamentals on the next couple here. Traffic processing sequence is super interesting. I would, if maybe you're not that familiar from a firewall architecture, stateful network scanning, I would embrace this not to understand it, but to expect it's going to be a picture you will continue to reference and even look at more detailed pictures from Palo Alto on the packet processing and the traffic processing. I think of this as like the next generation. What is that? How does App ID really work? This is the starting path to understand what exactly happens in a Palo Alto firewall. And later on down the line, this is a great source of truth when something weird is happening and you don't exactly know why, or when you figure out why, you're like, that doesn't make sense. The traffic processing sequence in the guide, and then Palo Alto has more detailed analysis ones, are really a map for how everything works on the firewall, but it gets quite complicated. So I think from this point, I would look at the big blocks. I think that's what they're trying to hit home on. This initial domain is really, what is the green box? What is the blue box? And they sort of break those out further in the guide. And I'm going to also just look at the clock. I know we want to get through everything in the hour, so welcome heckling from my team if it's like, hurry up, and we can keep each other on time. Panorama is the platform that manages all the firewalls. It fundamentally is PanOS. It has the same look and feel, but it's not a firewall operating system. Its design is to manage the firewalls. It's different than other firewall management systems. I, in the past life, did a lot of work with Checkpoint, less so with Fortinet, but it has its own unique architecture. And I think of it as it really augments a firewall. It can lay configuration on top in like an onion fashion. It can aggregate configuration, and there can be a path of hierarchy. But really, when you use Panorama, you can always log into the firewall and you can always log into Panorama. The management station isn't a full single pane of glass for every single thing that happens on the firewall, just from an architecture standpoint. And the security subscriptions, I'm not going to go into a whole lot of detail other than I think what I would keep in mind on these ones is really trying to describe so for threat prevention, what is the threat prevention in a couple sentences? Just getting the concept of it, I think, is at this point what the goal is. Throughout the exam, there will be a deeper dive on all these security subscriptions as well. And I'm going to pause here because what I want to do is actually pass it over to Nathaniel, who's had more exposure recently than I have on the BPAs and also the AI ops section. Nathaniel, did you want me to stop sharing as I hand it over to you?
I think that's okay for now, unless you want me to show like the actual AI ops dashboard. I can like show
that would be really cool.
Practical example.
Yeah.
But yeah. Sure. Let me just get this open here.
And while you're sharing, Nathaniel, I will say the exposure that I've had with the BPA tool is really what Palo Alto's done. It's a best practice assessment. They really had, thou should do X with the config. They brought this into a web tool. It's continued to grow. So that's really a little bit of the backstory about, where the BPA came from.
Yeah, the BPA. So starting this year, the best practice assessment is going to be moving over to this new tool called AIOps. And it is a free tool. It has lots of features just as free as a Palo Alto customer. There is a pro version, but I have less experience with that. It just adds some additional insights. But yeah, to explain the BPA, it's sort of exactly what it sounds like, a best practice assessment for your firewalls, your panorama, whatever you may have. It provides comparison to like the industry standards. It shows your adoption of all of the features of the firewall. So it helps you sort of focus in and see what you're missing out on. And it also gives you like recommendations. So if something is a pass fail or it is a fail, it'll let you it'll give you sort of an example of how to fix that, like a direct example. It looks at your policies, it looks at what you already have and gives you examples on how to fix that. So AIOps is sort of the same idea, except it's more of like an automated machine learning version of that. So instead of having to go and generate a best practice report, which you can still do in AIOps as well, it gives you like direct like adoption summary and overviews anytime you want. So it uses telemetry from the firewalls and collects some data and will give you sort of, it'll show you exactly the same information. Like this shows, for example, for our firewall, how much of these features is adopted. So you can see like a percentage, it's 23% not configured, data filtering, credential theft prevention. And then it also gives you a best practice mode. So there's a difference between things being turned on and then things being configured to the best practices according to Palo Alto.
Right.
So lots of ways to sort of build up your environment and get things working as Palo Alto recommends. It also gives you a way to generate alerts and send you emails if like things are not as expected in your environment. These are actually a bit more in depth than the firewall itself. It gives, like I said, machine learning, so it can actually take additional data and generate some alerts that you wouldn't normally see just on your firewall. And then, of course, send those out as emails if you so choose. And then just some general monitoring for your firewall.
It's definitely baselining thing.
Yeah, it's sort of, it's not a replacement for any other like panorama or anything like that. It's more so just an additional tool.
Yeah.
One thing I'd love to add, Nathaniel, or maybe just get you to explain a little bit, is the percentages in BPA are always kind of confusing to people, and that's one thing always comes up when we work with clients and we show a BPA. What does that percentage mean? And it's really about percentage of your firewall policy base that has these things applied. So it's not always applicable to all policies. So for example, if you don't have URL filtering on a internal policy, you will get docked points essentially for not having that turned on, because the percentage of your policy base that has URL filtering enabled may not be there. But arguably, if it's not going out to the internet, you may not need that URL filtering in that place. So that's one thing to keep in mind when you consume a BPA as a firewall administrator.
Right.
That's how the percentages are sort of calculated, is you're not applying it to that section. Doesn't always mean that it's applicable to something. And so even sometimes we find toggling something like URL filtering, even with like a blank policy, can actually lead to higher scores, which is somewhat, take it for what it is. So.
Right.
Yeah. Thanks for that, Paul.
Sorry, man.
Yeah, no problem. That's about all I have to say. We should probably keep moving.
Super
interesting.
We're
really bad at user ID, so even internally at Advantus360, we don't use a lot of user ID. So
yeah,
who knows? Maybe that's something we need to do.
It's a good point to raise, though, Paul. Like, there's context behind this that I think shooting for 100% without understanding what one layer below might be a wrong approach, completely wrong approach. Yeah, awesome. Okay. Thank you for that, Nathaniel. That was really, that was actually really interesting to see. I haven't seen some of the layouts, the formatting. It actually looks pretty good. I think I'm going to take a stab and assume that potentially the exam questions might be from a timeline context where some of this hadn't been released yet. So I would just add that, thinking about what might be on the exam questions, just keeping the timeline in mind, definitely reference the study guide for what's sort of in there from a reference perspective. But that is very cool that we got to take a quick.
Actually, one more thing to add.
Yeah.
So AIOps is replacing the best practice report, but you actually don't need to have firewalls onboarded into AIOps to use it. There's actually a way to generate the BPA manually like you would in the old tool. So if you just create a tenant in the apps page on Palo Alto, it just gives you access to that little section of AIOps that lets you do that. So you definitely don't have to send out telemetry if that's not available to you.
That's a good point.
There's the other way to do things.
Right. And I'm assuming Google is your friend, a partner like us is your friend, or your Palo Alto contacts are a friend to help out with those details. So that's awesome. We'll get some time back because we're going to talk about IPv6 and say we don't really do it. And Palo Alto does some things here. And I'm really going to leave it at that because I don't think our team has generally had a lot of in-depth IPv6 experience. I'm going to pause briefly and say there's going to be features there.
Only in zone protection stuff. Yeah, like zone protection, we turned on IPv6, like router advertisement blocking and stuff like that. That's about it. You have to enable IPv6 for IPv6 to be routed across your firewall, and it ends up adding a lot of routes and stuff. And we don't work with it a lot as far as I've seen.
Yeah, and I think it's probably, if you're wondering about that, I think if I think about maybe at your job role or where you are, it's probably worth a discussion with your network administrator or architect. Maybe you're the same person, and it comes into points of like, do you forward it on the network? We know Windows turns it on by default, right? Even on the server suite. So it might be there, and some of those aspects that Paul mentioned might be more relevant if it's there, but not actively used as a replacement to IPv4. All right, I think I will say one quick thing about Internet of Things. I think of how I think of this one, which might not be completely correct, but I'll just throw it out there. I think of Internet of Things coming back to device ID, and I think device ID in the similar way I think about app ID. It's another attribute as a match condition in the policy. And really, I think Palo Alto's take on this, much like it was very difficult to know what applications ran over which ports, there needed to be a better knob on the firewalls. They created app ID. I think that same challenge exists with IoT devices. They come and they go. There's hundreds. They're TVs, they're sensors, they're all of this, they're printers, and so many different types of devices running so many different types of operating systems. Device ID is an attribute to classify and say, I can craft a policy based on a certain attribute of an IoT device, and then they come and go all the time, and I can have some consistency in the security policy. So just to scrape from a high level, because Internet of Things is huge, that's what I think of when it's in the context of the next generation firewall. I'm going to stop sharing, Jawad, because I think you're going to dig in and talk about the next section, which is interfaces and zone types.
Yep. Thanks, Stefan.
Yeah.
Let me share my screen. Okay. Can you guys see my slides? Yep. Okay. Section 1.2, I tried to summarize what's in that section in a table here. So this is determining and assessing appropriate interface types. So generally, I would start by saying that the nice thing about the Palo Alto is that it supports various types of connectivity and interfaces, which provides that flexibility when deploying the firewalls in different, let's say, environments or network setups. So starting with the most commonly typed, the layer 3 interface for you who have configured or deployed Palo Alto firewalls, you probably configured it. High chance you configured it in as layer 3. So that's where the firewall is participating in routing. You're assigning IP addresses on the interfaces, and it's routing traffic between those interfaces. Requirement for this one is to set up a routing table, or what we call virtual router, on the firewall, where you configure your static routes, or if you're participating in dynamic routing, most commonly OSPF and BGP, this is where you'll be configuring those. Another interface type is layer 2. So if you're doing switching instead of routing, you would configure your interfaces as layer 2. One use case, for example, that I've seen would be like a small office or home network, where you're trying probably to get away without using a switch or switches, or you have one broadcast domain where hosts are, in the same VLAN or same broadcast domain. This would be a scenario to configure a layer 2 type of interfaces. In relation to this, there's the VLAN interface, which is a logical, basically, interface that you can configure as well, similar to what you would do on a Cisco switch, for example. This will provide like a layer 3 gateway for your layer 2 network. Again, this is a logical interface setting where you can define an IP address and basically provide a gateway or a route out to your layer 2 interfaces. Another option, you can configure your firewall or interfaces on as vWire. This is transparent mode. This is in situation where you don't want to do any network reconfiguration or changes. You just basically inserting the firewall as a pass-through, and basically you don't need to assign any IPs or MAC addresses, anything like that. So it's a simplified, basically, deployment of the firewall, mostly used in situation where you can't or you don't want to do network changes. And the firewall configuration, it's worth noting that the default configuration of the firewall comes with 2 ports, Ethernet 1 and 2 are configured as vWire ports. And therefore, out of the box, inserting the firewall, connecting it, you're going to get traffic through these vWire, untagged traffic through these vWire interfaces. And then we've got TAP. That's another mode you can also configure. TAP, basically, if you have an existing network, you don't want to deploy the firewall in line yet, but you want to gain that visibility. You can forward like a mirror or a span port from your core switch into the firewall, so that the firewall gets that visibility, and then it's providing that IP app ID identification and log visibility on your network. One use case would be evaluation. If you're for new customers evaluating the Palo Alto, they could deploy it in this mode, get that visibility. Maybe they're not ready yet to administer or configure the firewall otherwise. That would be a good mode to deploy it in initially. Another use case would be like in a Cortex type of environment, and you want to add more sensors and get additional logs. You could also deploy a firewall in tap mode and get logs forward this way into like data lake or the Cortex environment. Okay, moving on, more interface types. We've got the HA. So on the higher firewall models, usually those are dedicated ports. But on like the smaller models or some of the older models, you might not have those as dedicated ports. And if you're setting up like firewalls in active, passive, then you can leverage data ports and choose interface type HA and configure those to be dedicated for your high availability connection. Then aggregate, this is probably you're familiar with it. You're aggregating multiple links. Again, this is a logical interface type where you're combining or aggregating multiple interfaces. One common use case would be downlinks from the firewall to your core switches in the data center. For example, Cisco switches and other type of switches, they support like a VPC type of logical connection where you can combine ports on different switches logically as one link back to the firewalls. This supports both layer 1 and layer 2, like our LACP configuration. Usually, the firewall side of things is configured as passive on the LACP, while the switch would be active. That's the most common configuration there. You can bundle up to 8 ports. And one thing to highlight would be that you can combine ports of different media, so they don't have to be the same type. You can combine fiber and copper, for example, in the same aggregate group. However, speeds and types, like layer 2, layer 3, interfaces should be the same in the same group. Moving on, another logical type of interface is the sub-interface. And this is very commonly used, especially on when you're trunking for trunk ports. So think of a data center connectivity where you're segmenting several VLANs or networks over the same link. Then you're creating this on Palo Alto as sub-interface and assigning the VLAN tag and the IP address if it's a layer 3, or just the VLAN tag if it's a layer 2. And this way you're trunking different VLANs over on the same link on the Palo Alto side.
Very common. Most of our,
Yeah.
I think most of the deployments have sub interfaces and that. Yeah.
Yep. Moving on, another logical interface type is the tunnel. Again, I think most of you are familiar with this. One common use case is IPsec VPN. So you're configuring the IKE physical link through the physical IPs, but then you're creating on top of this the logical tunnel interface. And on the Palo Alto, this is route-based versus on other firewalls, it's usually policy-based. So with route-based, it just has to be added again, and the virtual router that has the physical interface, and then define a static route. And this is what will initiate traffic over the tunnel. Having said that, the Palo Alto still supports, if it's doing an IPsec tunnel with, let's say, a proxy, a policy-based firewall like Cisco or other vendors, it still supports doing that through proxy ID configuration. But those configuration additional routes or tunnels you're going to add will count up towards the total number of tunnels you have or supported on this firewall. One thing also to add, that in most cases, you don't need to add an IP address on the tunnel itself, unless if you're doing tunnel monitoring in case of tunnel redundancy, or if you're using or you want to participate in the dynamic routing, then usually you'll assign an IP address on the tunnel itself. The next one, again, another logical interface type is loopback. Very similar to if you've worked with routers and switches, very similar use of that to assign like an ID and BGP, for example, or SPF. You can use loopback, but in addition, there's other uses of it that I've seen in Captive Portal. And if you have multiple global protect and you're trying to decouple the outside IPs from internally, you can NAT it to a loopback IP address this way. Special NAT, sometimes you can do some workarounds or special NAT configuration, also using loopback interfaces this way. And then the last interface type is the decrypt mirror port. Again, this is a logical interface. This is the use case for this one would be if you're decrypting traffic on the firewall, but then you want to forward this decrypted traffic to a third-party device to do additional things or specific things like DLP kind of inspection, then you're using this port type to achieve that. Any questions on any of the interface types?
I think it's a great summary, Jawad. One thing I'll add, just if anyone wants to type a question in the chat or unmute, but I do know one experience I'll share is the vWire interface is very simple until you do high availability. And then if you add VLANs through that, it becomes very complicated when you think of HA failover, spanning tree, ports coming up or down. So I would say just as experiencing that through deployment, a wonderful interface type if it's a single firewall, just a quick insertion, a lot of deceptive detail required and complexity if it's in that data center topology you were describing, Jawad, from with those layer 3 interfaces. Just wanted to share that.
Yeah, no, great add there. I'll also, I'll add that like you don't need to go one way or the other. That's the nice thing on the Palo Alto.
Yes.
You could have portion of your, interfaces or layer 3, and then if you have like a legacy network that you don't want to do network changes or basically have the firewall participate in like layer 3 or layer 2 communication, then you can have vWire set up on that specific, let's say, network. Maybe I failed to mention vWire still supports most of the features, but there's like US decryption, NAT, of course, like access control, all of that. But there are gotchas like Stefan mentions and some consideration around it. I brought up this diagram because it's in the study guide and they have a complete page on it. I've not seen this in like real life, but probably they're demonstrating a use case of segregating different customers through VSYSs, which we'll talk about in a later section, multi-VSYSs basically, and vWire, and using things like VLAN tags and IP classifiers basically, again, to segregate customer traffic over this, going through the same firewall, more in like a managed service type or ISP type of provider that's serving multiple customers. So yeah, I advise like read through that section just to get familiar with this very specific situation there. Okay, moving on to section 1.3 is decryption, identifying decryption deployment strategies. First, we'll start with what's the need for decryption. SSL traffic, encrypted traffic is on the rise, so firewalls are having less and less visibility in terms of traffic identification and inspection. So we know that command control botnet kind of attacks, they try to hide into SSL traffic. Also, there's chance of data leak from internal to external, like exfiltration, whether intentional or unintentional, could happen also through SSL, through like cloud storage, other ways as well. And then finally, you probably want to have that good control on your ciphers and on your certs and on legacy protocols. And you can achieve that in a better way doing decryption. Advantages with doing decryption on the Palo Alto would be that you don't require any additional license for that. So you can configure it right away. You don't need any additional hardware or components other than your firewall. It's very flexible because it's policy-based, so you can control exactly what you're trying to decrypt in your environment. And then it's provide a better, it doesn't have the same limitations other solutions have, like web proxies would only inspect port 80 and 443, not other traffic. ADCs require two, for example, appliances to do decrypt and then re-encrypt. And then if you're using dedicated appliances, that's an additional investment and more configuration and overhead for the administrators. There are building blocks, definitely. Things need to tie in the decryption, like user ID, certificates, URL categories. We'll talk about those more in the next slides. And then there's considerations and prerequisites. I think the main message here is like you can't turn on decryption and hope for the best. There are things need to be planned well. Like you need to plan well your how you're gonna do the certs, how you're gonna issue the certs, manage the certs. There's gonna be overhead when decryption is turned on in terms of the load. There's impact to policies because now you're identifying more app ID. And then there's things that don't work well with decryption, like it could break technically, pin cert, mutual authentication, other things. Those need to be excluded from decryption. And then there's non-technical consideration, like from legal and HR perspective on maybe things you don't want to decrypt, again, from those perspective. Types of decryption on the Palo Alto that are supported by Palo Alto. There's 3 types of decryption. First one is the SSL forward proxy. So this the most use case for this if you don't control the server side of thing. So think of internet traffic where users are accessing internet or services on the internet. You don't control the server side of things, then you have to do SSL forward proxy for that outbound traffic. And this is a very common use case, decrypting outbound traffic for users. Certificate requirements for this would be forward trust cert issued, recommended to be issued by your internal PKI. This has to be a sub CA, and the firewall needs to have the private key. And we'll talk about that more in the next slide. Next type is SSL inbound proxy. This is when you control the server side. So think about your published services. You own the cert of that server, then you can do inbound proxy or inbound inspection. And for this to work, you need to load the server certificate on the firewall with the private key. And then last type is SSH proxy. Common use is avoiding like circumventing SSH tunnels or tunneling through using SSH tunnels to get away, from inspection or URL filtering. So you want to avoid users doing that. And then there's other type of attacks could happen through SSH as well. So SSH proxy is simple. It doesn't need any certificate, and you can deploy it just by applying decryption policies, basically.
Your host keys just change. That's all.
Yeah. Okay, just showing basically forward proxy. Again, the main point here to highlight is that the firewall is acting as a proxy middleman here. So the user initiates a connection to a website. The firewall intercepts that and then reinitiate this from itself to the external server. This could be like Google or any external website. The website responds back for verification with a certificate. And then the firewall again is on the fly here. And this is why it needs that sub CA. It's going to reassign the cert and present it back to the internal user. Because this is issued from the firewall, which is your internal sub CA, then the end users are trusting that certificate basically from the firewall. And then the key exchanges, again, this is happening between the end user and the firewall, and then the firewall behalf of the end user to the service, to the server. And just again, another point to highlight, anything outside the firewall in out is encrypted, and that decrypted traffic is only on the firewall side of things. So it's getting decrypted at the firewall and then re-encrypted before leaving the firewall.
Right.
Unless you're decryption port metering or something, which you're allowed to do, but only.
Yeah, right.
Inbound is a bit different. You have the server cert loaded on the firewall. The user is directly communicating out to, or external users are directly communicating out to your server, and then the server is sending back its certificate. The firewall is not proxying that session, but because it has the same cert that's on the server, it's basically transparently decrypting and doing all the content inspection on the fly as this traffic goes through. So less intrusive than probably the forward proxy in this manner. There might be some edge cases, some type of encryption where the firewall in this case might be forced to fall back into doing proxy if it's not able to do decryption this way. Lastly here is decryption profiles, just highlighting that through decryption profile, you can have even more control on what, for example, TLS versions to allow in your environment. We know that, for example, SSL3 is not secure, so you can basically disallow users from hitting sites that has older TLS or SSL versions. This way, you can control what encryption algorithms also you allow. And you can even block on specific expired certs, untrusted cert, or certs issued by untrusted issuers and things like that. This can be achieved through decryption profiles in conjunction with decryption policies. Yeah, that's all I had. If anyone has any question, otherwise I'll hand it back to you, Stefan.
Thanks, Jawad. Yeah, I'll maybe actually throw out two questions. I know time is flying by, but I'll make them quick. One that with this screen you have on, Jawad, which is actually great, and you guys, I sort of know it from a one step removed, but I think you guys have run into this. If you're not in a somewhat current PAN-OS version, often there are these check boxes aren't all there, and therefore decryption may be suboptimal, or there might be some challenges with the deployment if you're many major releases behind on PAN-OS. As new encryptions come out, older ones are deprecated. So that's something I think we've run into, right, guys, where if you're really doing a decryption deployment, you should be on the newest possible within reason version of PAN-OS.
Yeah, especially PAN-OS 10 adds great features that help with troubleshooting, like decryption logs, and the ACC has also additional sections. But then there's support of additional things like TLS3 and Cypher suites, the higher versions.
And you're absolutely right, Steph. It's not even just things that are on this list. It's also things in the back end that just aren't in the version of PAN-OS because they weren't developed or standardized at the time. There's other things like NIST curves are standard approach to Palo Alto. They don't use Microsoft curves, for example. So there's curves like X255, 2515 or whatever, which are Microsoft and non-NIST standard. Palo made a statement that they weren't going to support them. They've actually changed that. They're going to support them now in new versions. But yes, if you're on the latest version for decryption, you'll get the latest Cypher suites, you get the latest curves, and the behavior, if it can't decrypt, is to bypass, right? So if you, it's not a drop when it can't, it's an allow if it can't. So if it can't decrypt it or it's not able to, it bypasses it.
Right. That makes
sense. The other
sense.
thing that always gets us is no decryption, not gets us, but gets a lot of people, I guess, generally, managers, firewalls and things, is the no decryption policy still applies if the policy matches and it's no decrypt. No decrypt can block things like SSL Cypher suites or old protocols, even if you're not doing decryption or proxying. And then the third thing we always get is, because the Palo is the man in the middle for the connection outbound to the internet, it's the Palo cert store that needs to trust an external host. So if your computer has all of these additional vendors on it, like Foxit or Chinese web certs or whatever, the Palo doesn't have those loaded on it. So if your computer trusts the website, but it has to get proxied through the Palo cert store is what has to make the determination if it's trusted or not.
Right.
And because it
Right.
resigns the certificates, if the Palo doesn't trust it, it resigns it with a non-trust certificate, because everything the Palo passes back signed, it will be trusted by the computer, even if the Palo doesn't trust it. So another consideration is the Palo must trust it based on its internal cert store so that it sends on a trusted cert to the user. And if Palo goes out and gets untrusted because it doesn't have it in the cert store, it will send an untrusted cert back.
Yeah. Yeah.
That's the third one that we always got.
Yes. I'm going to ask this other question with a chance for you guys to say, let's skip it and move on. When you had the picture, Jawad, about inbound inspection, I always thought of this as a side channel copy, but I don't think that's. I think there's more there, right? And maybe you can maybe even like leave me with a sentence or two, Paul, Jawad, or you can say it's another topic, because I always thought of it as like with the private key, you can read everything, and then if you see something bad, you could drop the session on the firewall. But it sounds like it's a little bit more advanced with that in newer PAN-OS versions.
It's certain cipher suites and certain modules, they have to actually basically proxy the session key that gets generated for that session. So even though you can side channel attack with the private key, if you don't own another piece of that algorithm, you can't do that. So you end up having to proxy part of it anyway. So originally it was purely a side channel attack, but there's protocols that you need to proxy.
Yeah, like the newer ones, right? Like HTTP2 or TLS3.
Right.
Yeah.
Okay, that helps, and probably maybe a little bit beyond the depth needed at this point, but actually that's really interesting. Thank you guys. I hadn't run into that.
That caught me
thank you,
I thought it was purely a side channel attack for a long time, but that's not the case. It does actually proxy some elements.
And it makes sense. I think we'll go to you now, Paul. We will go to the next sections are, well, you
User
know
ID.
them, Paul.
Yeah, man.
User ID. Yeah.
And I'll try to be really quick because we're cooking through time here. So
that's okay.
I'm gonna.
If we stretch a bit, I know some of the people who've joined us might have to drop, but let's definitely, if you guys are okay, like if we end up having to go over a few minutes, we can round it out just so we can mark it complete. But all right, all yours, Paul.
Okay. So user ID is effectively the means of which to control policy based on this other match condition they call user ID. And user ID in its simplest form is a mapping of a username to an IP on the local firewall. Basically, it's a database. It has an IP field and it has a username field. If these things match up, then it's able to affect policy based on user ID. So consider there's an IP and a name, and then name goes to group. And so when a session comes in, it just reverses that order. It says, what's the session from? Is that session on my local table that associates to a name? Is that name either in the policy or is it part of a group that's in that policy? And then it can allow and deny based on that. So that's user ID in a nutshell. So the question is, how do you get these mappings? How do you work with these mappings? And how do you basically make policy to affect these mappings? So, or use these mappings. So let me actually see. I apologize. I'm gonna, whatever. You guys can see me. Hopefully you guys can see the screen where user ID is. I'm gonna go through these sections. So yeah, that's just basically the mapping. So the firewall is a local database that has this mapping between IP and username. And then how do we get that? So the most common is user ID agent or agentless, which is one of the things we need to talk about. So Active Directory has a success authentication log, essentially. You can request it using either an agent that has permissions to access that file using basically DCOM reading of, like it's a DCOM remote reading of a security log file. And what it does is if someone has a successful login on that security log file it's processing, it takes the username that's successfully logged in, takes the IP that they got sourced from to the Active Directory, and it puts it in that mapping table. Now you can do this based on an agent, which is a piece of software you install on a computer, or the Active Directory itself. If it's on the Active Directory itself, it reads the file locally. If it's installed on a remote server that's joined to the domain, you give it permissions to read this file, and they're quite high permissions. You basically have to allow DCOM reading of this very secure file. So there's some permissions there you got to deal with. There's other ways to get user ID mappings, not just Active Directory. So you can do it from like syslog, for example. If you have a system, let's say a wireless controller, and it's handing out IPs, and you have a successful login because you did your, EAP or whatever, your, wireless authentication, the wireless controller goes and authenticates on the back end, what the Active Directory is going to see is the wireless controller, because the wireless controller is the IP that's connecting to it successfully and authenticating this user. You don't want everyone to show up underneath the wireless controller's IP, so you need to get the wireless controller to send you the information of who authenticated to it, that it authenticated proxy to your Active Directory. So you would then do something like syslog, where the wireless controller can syslog out to the management port, for example, of the Palo, and you can listen to those things. Syslog user ID needs to be enabled on the management port for that to happen. And then you can create filters, basically regex expressions, and then you can grab the mapping of the username and the IP, and that will then add to the table mapping that is used for user ID. You can also do XML API. So if you have some sort of central system or SaaS service, you can directly talk to a XML API interface on the Palo's management, and you're able to basically push mappings directly to it. You can say this IP is this user, and it will add it to the local database. So that is how to get IP user mappings into the thing. Agentless versus agent, just really quick on that. So agentless is when you give credentials directly to the Palo. What the Palo is going to do is basically those DCOM interface connections directly to your Active Directory. Now, there's some concern about agentless that I've heard, and mileage may vary, and maybe updates change this. But for example, client probing is something that is sort of available, but people like to move away from. So let's say you give the permissions to the firewall to directly do these sort of DCOM remote operations. There's a feature called client mapping, client probing, which is when it doesn't know the user that's logged into a system, so it has an IP address and it shows up. That IP address is unknown, there's no mapping. It can execute basically a remote query using very advanced credentials, like administrative credentials, to the device itself. Imagine your Windows laptop gets logged into remotely through the Palo using this permission set. And if this permission set then can use a query on the system once it logs in to say, hey, who's the currently logged in user? And that's able to make a more just-in-time mapping on the firewall. The problem with that is if I'm an attacker and I'm an unknown attacker, but I'm listening, the firewall's sending me these credentials essentially. And if I modify the way I respond to those credentials, I can essentially capture hashes and things like that of a very sensitive permission set. So we definitely shy away from using client probing these days because the firewall is sending those arbitrary login commands. And if an attacker is in that area, and if you don't trust computers in that area, they could arbitrarily sniff that data and potentially turn that into hashes, which then you can do like pass the hash stacks and things like that. So client probing, be careful. That's the threat there. Agentless is generally okay, but again, it's sending those credentials, but it's sending to a specific location. You're saying this is the Active Directory I want you to log into and get that DCOM file. So agentless and agent, those are the differences. There is more CPU use on the agentless side. It's basically using the management CPU to pull that information. The agent-based side, what happens is you essentially connect to this agent, which is a piece of software. It opens up a port 5007, and it just gets those queries back through like an SSL channel, basically. And then the agent software itself queries either locally or remotely using those permissions. Okay, so that's how to get mappings in through different mechanisms. Let me actually scroll down to what I'm showing because there's lots of, obviously. Oh, port mapping. So there's a different agent called the Microsoft. So there's a terminal service agent. Now, if you guys are familiar with terminal services, they allocate source ports to users. So user 1 logs in, they might get like 1,000 to 2,000. User 2 logs in, they get like 2,000 to 3,000. So when they execute commands, the operating system only puts that user's information to certain port ranges. Now, if a user is doing queries, the Palo needs to know that because there's multiple users logged into a system. Typically, if a laptop is a laptop or any other system has a user logged in, if another user logs in, the last one who logged in will own that IP. It's a good thing to note. If you have a remote administrator log into someone's laptop remotely, and they're the last person to log in, and then they log out,
Right.
the last person who logged in will actually consume that IP. And so the user ID technically allocated to that IP address will be the last person who logged in, just to note. So when you have something like a multi-user system, you need to know those port ranges in order to allocate the user space. It means if the source port starts from this range to this range, it's this user. But if it starts from this range to this range, it's this user. So there's a different software for that called the terminal service agent or user ID terminal service version. Okay, I think I covered all of that. Hopefully you guys got some Global Protect will automatically grab information. I mean, it has an agent, right? It has the actual
Right.
host information on that. So it does automatically gather user ID information for you. Another way is the browser form or captive portal page. So if you hit the captive portal page, which is essentially a web page served by the Palo Alto, you can force this page to jump up, for example. If you don't have user ID, you can, we're going to talk authentication policy later, but you can basically cause this page to pop up. Because the page is owned by the Palo, the IP address that you hit that page with essentially becomes the IP address that you're getting mapped to. So if you log in successfully and it proxies a connection on that web page, the IP address that you hit it is going to become your mapping to the successful login. So you can do that as well. That's called browser challenge or web form. Okay, and then so here's a diagram of like, look at all these things you can feed from. And that's the whole point here is if you have a complete, satisfied, let's say, internal database of IP to user mapping, you can apply a policy based on user ID, which again, just goes back to an IP address at the end of the day. So agentless, if you're small, medium, they say don't go higher than that, again, because you're going to be doing lots of queries off of the firewall. They don't want to consume that. Windows ID user agents, normally what we get, it's a very small piece of software, but it is a piece of software. If you want to avoid piece of software, you could do agentless, but generally we work with user ID agents. Redistribution. So you can take that user ID table, which is that onboard database, and share it. One firewall can actually pull in another firewall's 5007 port on its management to get those user ID informations from one firewall. So you can have two firewalls basically share the user ID information. If they're querying different things, you can share amongst each other. I've definitely done this for active passive environments, not in the firewalls themselves. They share that information between the active passive clusters, but between things like a DR site. So if you have an active site and you have a DR site, I have shared that information between the active site and the DR site so that if something fails over, the table is equivalent in those. Especially when you're logging someone in through a web page over here, like through the web form portal, and you get that information locally only on this cluster, you need to share that information to another cluster because they won't have it. So consider redistribution.
Question for you, Paul. Is there this scenario, does Palo Alto support where a name can map to many IP addresses, or does one push out the other?
Oh, yes. No. So, okay. So one IP is always mapped to one name. You cannot have one IP on multiple names. The last name that came in is the name that overwrites the IP. So it's an IP centric, but you can have multiple IPs to a username. So Paul can have a phone and a laptop, and he could have logged into a web server, and all of that would be, all those IPs would be mapped to my user ID. Great question. Okay. But yes, it's a first in sort of situation. So if I have an IP 1111 and Steph owns it, and then I log into the system 1111, and the source here gathers that and sends it to the Palo is going to replace Steph's name with Paul.
That's actually, I always thought of it as like things that map to the user, but it's actually IP centric, which makes sense. So there is only one name can map to an IP, but there could be many IPs at the same name. Awesome.
Yes, and there's ways to control this in software because this does raise problems. Common controls or jump boxes. If you have a jump box with multiple people jumping in and you don't have a terminal service separation of port, you have the last person always owning that. I'll give you an example. Let's say you have a policy and that policy says admins have access to this area of network. If you're on a computer and the admin remotely logs into your computer, Active Directory will actually say the admin is now that IP, right? Because the admin successfully logged into that IP. User ID will update. User ID will then say that the IP is the admin. That user's computer now has more permissions than it should for a time period until it times out. Or it gets an update in Active Directory. If someone logs out, logs in to their laptop, for example, it would refresh that and take that IP over again. So there are problems there. There are solutions to those problems, like everything. For example, if you have an area of network that's considered administrative local, you can drop those or filter on those. So if an admin's always logged in from a box considered an admin box, you can say, I don't want to update user ID based on this subnet. That's include exclude lists inside the user ID agent software or inside the agentless software. Good stuff. Thank you for putting me on questions. I always do better when people are
that's
like,
actually
hey,
that's a real one because I had always thought of it the other way. So thank you, Paul.
I'm happy to help. Yeah. So that's redistribution can also happen through Panorama. So if you have a very large distribution, you want to gather and you want to push those tables up and you want to go to a central place and you want to pull that information back down into your firewalls. Be smart about this. You can create some very interesting kind of looping scenarios where like you push and then you push and then you push and then you grab back to the first one, and that causes like a push and push and push. It's pretty good, but yeah, just mappings can be done, like I said, by basically sharing information through the management ports. Okay, yeah, I'm totally over time. So multi-factor authentication. Really quick, user ID information can also have an additional criteria attached to it on the local table that it has with an MFA timestamp. And that can be centered around a timeout value. If someone successfully authenticates to multi-factor, this can be done through multi-factor authentication, it can be done through a web page portal, any of those. They can be considered then valid, and that timeout will last and allow them to access the authentication policy. So then what's the authentication policy? Well, basically the authentication policy is when there's a different policy base. So you can have user ID enforcement based on your security policy. You can say, Steph or Paul can access this firewall. And if, again, the IP lines up to that table, then that session will be allowed on first come, right? Again, when it's fast pathed and it times out, you'd still have the session available. So consider that. Authentication policy is another table. It's a different policy entirely in the firewall. And what it says is this person must be authenticated before they can execute network sessions to this endpoint. If they don't, you can cause an action to occur. That action could be, for example, prompting a web browser or requiring basically them to authenticate. So in this way, you can force multi-factor authentication on network flows.
Right.
Yeah. See if they have a good picture here. Yeah, so it's a different policy base, and you basically can force that someone must be authenticated before they execute that action towards that destination. Source, destination, policy match, and if they are authenticated, then they can pass that policy, and if they're not authenticated, it either gets dropped, depending on the application it is, or it could force a browser challenge. So what I mean by that is if it's port 22 or 25 or anything that's not web or SSL, it will just drop, actually do a TCP reset. So it'll do a TCP reset on the flow and basically say, you're not authenticated, so you can't access this resource according to this policy. If it's 443 or 80, it'll attempt to get an authentication from you. And that basically occurs by way of a web browser challenge. So it pops up the Capture portal page, you log in, and that causes authentication, and then it can continue that session. You do need to make sure that you have SSL encryption in place if you're trying to pop up inside the session that's been formed to a web server that's SSL. So for example, if you're going out to a secure location and the authentication policy says, no, you have to be authenticated to access that resource, it's going to try to force a response, basically forged from that, to say you must authenticate. When that occurs, if it's an SSL channel and you can't decrypt it, then it will basically break the channel because it's trying to inject unencrypted or wrongly encrypted data into an encrypted channel. It'll break that session. You'll get error pages. If it's 80, it's easy. It just injects basically a forged response back to you, and then you log in to the Capture portal page that shows up, and then it continues that session. If it's anything else, it just responds to it by basically dropping or resetting the connection. If it does reset that connection, there's a feature you can integrate into the GlobalProtect software where it will send a UDP message, and that UDP message will hit a client, and that client will then get a pop-up on the bottom part of the GlobalProtect software. They'll get a pop-up and it says like, hey, you just got blocked because of authentication policy. Please click this link. And by clicking the link, it opens up a new session to the Capture portal page where you can authenticate. Once you're authenticated for the time period specified, you can then go back to that session you were trying to do, and you would then pass the policy because you are currently authenticated. So again, authentication policy is basically, is your mapping exist? If no, drop or challenge. If yes, permit through. And that is different than the authentication, than the user ID column used as a match condition in your security policy base.
Right.
Cool.
Conceptually, Paul, would I think of this as like, first you have to pass the authentication policy rule to get to the security policy rule?
Yes.
Okay.
Yeah. In practice, it's kind of the opposite, but because, yeah.
I know. And that's maybe double clicking on the packet flow, right? Like you can't do
Yes.
app ID on packet one. Probably
Yes.
is what
So
you're getting at. There's
yes,
some
because
pre-set.
Yes. Day in the life of the packet or the packet flow would be absolutely crucial to understanding that flow. It's a little convoluted because if it doesn't match the security policy base, the Palo throws it out like really, really early.
Yes.
If it matches, then it goes and checks if their user authentication policy associated to that. Because if it's allowed, right, and it depends. If it's like app, it goes later in the flow
Right.
and everything. If it's just based on port, it'll go pretty early. If the port's allowed, it'll then check, do I have to check its authentication policy? And then if it
Right.
says, oh yes, it does need to go in the authentication policy, then it checks its onboard database and says, is there a matching? If there's a matching, then you can allow the person through. If there's not a matching, then cause the action of authentication policy.
Right.
But
No, that
authentication
makes
policy
sense.
can also drop traffic. So it's a little,
Right.
it's a bit of a combination of both.
Yeah. I guess like a security feature could too, though, right? That's not.
It actually acts as a
yeah.
security feature essentially. So
Yes.
if you want to think of it that way, it's like, does the policy match the first like raw TCP
Right.
requirement? Then take action on that. It's part of that take
Right.
action where you get this stuff.
Right.
Okay. Captive Portal Global Protect client is just when you get that pop up. Yeah. Any questions? Because I think that's really user ID in a nutshell. Oh, I'm sorry, group mappings. So group mappings is basically you give the Palo LDAP permissions to do queries against your Active Directory. It's able to pull group mappings for the groups you specify. So it doesn't grab all the groups, you have to specify the groups that you want to pull basically.
Right.
But if it has those, it'll do queries against those groups and grab the users who are associated to it. So once it has the user ID and it knows your domain, it can basically look at like, oh, is that part of that group? And so back to your policy, if you're on the user ID column of your policy base, you could say, allow help desk group to go here. And what it's doing in the background is it's going to check its onboard mapping that it has from the last time it pulled, where it says, is this user, sorry, it sees a session come in, right? The IP is going to get mapped to a
Yeah.
user based on the table. Then the user is going to get mapped to a group based on the match condition or the group mapping table. And then it can then say, yes, group help desk is allowed because this IP matches this user and this user matches this group. So yes, the group that matches the policy base and can be permitted through.
That makes sense. So you could write a security policy saying this group can access this resource.
And it could be group,
sequence of
groups,
events you
group
talked
plus users.
about. Yeah, is how it's still allowing an IP address in the session evaluation.
At the end of the day, it's still an IP address. And so that's
Yes.
the critical part. At the end of the day, it's still what the firewall sees, which is a session, which is based on IP address. It just uses this additional information to sort of allow you to get further out from the session based on these mappings, right? So that's the power.
Yeah.
I'll stop there. Any questions, or do you want to do questions at the end? I guess we're at the end.
No, like I'll maybe do a recap just to compartmentalize it, and then we can hit on the management plane, data plane, VSys, and then we can see if there's
actually,
any
I'm sorry,
questions.
Steph. Could I jump into one more thing I have in my notes?
You can.
Cloud Identity Engine is something that's basically in the cloud, and it can do group mappings for you. So it can grab from like Azure Active Directory if you want, cloud to cloud, and then Palo can connect to this to get the mappings from it. So you don't necessarily have to do it through the Palo. And then, user ID hub on multi-visa systems. So we haven't talked about multi-visa systems, but basically their local databases are all separate. And so if you want to share information between them, you have to create a user ID hub. You pick a VSys that's like your core and you check a box, and that box then allows you to share that user ID information amongst all the different VSys that were otherwise segmented. Sorry, Steph, that's it now.
No, well, and I'll ask one question. Maybe I'm oversimplifying things, but if I am a customer that uses Microsoft 365, I have Azure AD, I need the Cloud Identity Engine if I want to link into username IP mappings, or is that not
group mappings?
Yeah. Group mappings. Right.
Group mappings. Yes. The user to IP mapping is still going to be based on information otherwise gathered, right? It's going to be based on something else. Group mappings is what Cloud Identity Engine syncs. From what I understand, it doesn't sync user to IP mapping. It's just too fast. It's too much change. I don't think there is that connection right now.
Right.
Yeah, but group information, group user object synchronization.
Yes. Yeah. Which is this group has these members, is how that's constructed. Right. Okay.
Yeah.
Awesome. Thank you, Paul.
Of course. Happy.
That's good.
Happy
All right, let's go to, actually, if you want to go to page 54, Paul, you help me out.
Okay, 54.
Yeah.
Not too far.
Actually, am I jumping around? See, I might jump, I am going to jump around. I'm actually going to give you another one first. Sorry, Paul. Let's
Okay,
go
no.
to the picture. Let's go to page 49-ish to talk about data plane and that. Yes. So there's a construct here that is not completely unique to Palo Alto, whereby there's a management plane, a data plane. These are two different processing units on firewall hardware. They are different hardware components potentially. Smaller firewall hardware, and then the VM series, they can be more of a virtual construct, not a hardware separation. But within PAN-OS, they are very different things. I think for this domain in this exam, you really want to understand that there are two. You want to sort of understand what they're about. And in this picture is at a glance talking about what types of elements are processed in either the control plane or the data plane. Those would all be good things to sort of work to understand from an architectural standpoint. And thinking about applicability and what we've run into, I'll go back to very archaic Cisco gear. When you typed in a wrong command or you had a bad day, you lost everything. You might have not had traffic. You might have had network traffic issues. You might have had like no response on the command line. There's separation here. And in some cases, there could be problems on either side of the fence. And I know one we've run into is where the management UI is broken, something's not looking there, it's not responding, but the firewall is still forwarding traffic. And that might be an example where the data plane's fine, packets are coming in interfaces, going out interfaces, but something on the management plane isn't correct. And we've even had cases where restarting services or daemons, essentially, those commands usually have a component of, is it on the control plane or the management plane? And then I'll get you to browse to that first page I mentioned, which I actually lost the page
54.
number.
Oh,
Thank you, Paul.
I just passed this guy.
Yes, and just sort of more so on the bottom, I just wanted to, on behalf of Mohammed, talk a little bit about vSys. So the firewall the PAN-OS operating system, I believe this feature is only available on certain levels of hardware firewalls. You can segment that hardware firewall into many separate logical firewalls using the vSys or virtual system construct. This is not quite as straightforward as some other vendors have implemented it, in my experience. And you will find you can do things that are very flexible, like have a trunk port, like in Jawad's section where he talked about this is how you connect to a network core, and sub interfaces, which are logical interfaces mapped to zones, can be split between vSys entities. So I think for this point, and from a high level, knowing you can split the firewall and segment things, they get into a little bit of a context about how they would leak traffic between vSys, meaning technically you could have interfaces and have it go outy vSys 1, any vSys 2, but the construct they talk about in external zones is a way to bridge traffic on the back plane between vSys essentially. And actually, if you scroll up, Paul, there was one sentence above that first picture that sort of hit it home for me that I sort of found comical, where they say the external, a little bit down,
Okay,
right? That's okay. The external type forms a network of sorts. I thought that summed it up really well because I feel some of the vSys items are a little bit fuzzy and not well defined. So I give them credit for being honest to maybe how I see things, and what it says forms a network of sorts. Yeah, what does that really mean? It sort of bridges things. It's not quite as black and white. But again, this section I would focus on learning the basics of vSys, the elements, what is the external zone, because that's, I believe, only when that zone type is used. and those types of pieces. I know one thing Mohammed was going to mention, I think, which I'll add, is really some other vendors and products you can allocate a percentage of resources to a vSys, and you cannot do that on the Palo Alto firewall. So there are some caveats when going down the road of vSys that you want to be cognizant of. So if there was a lot of traffic in vSys 2, you can't segment and say you can only use half of the pie. There's not that granular control. And in addition, there's some system features and things like PCAP and basic troubleshooting that you have to do from sort of a base level, which means you can't truly carve up everything under the sun into different vSYSs. In practicality, I'll just say from our deployments, we have seen some enterprise customers that have deployed vSYSs, but it's the same admin team. Everything's the same, and they thought maybe vSys, using the vSys feature would give them a better design. And in the long run, they all appear to unconfigure this or simplify it because you see multiple logs, multiple in and out, you're processing the traffic multiple times. And when it's the same admin team doing all of those things, it's really usually suboptimal. So the cases might be if you have multiple admin teams, maybe one admin team is managing the box and then they delegate certain functions to other teams, might be a good case for vSys. And then I'll wrap up with I wanted to do just a recap, and then we'll open it up if you guys have any questions, just to sort of round this one out and go from there. But fundamentally, and it's nothing else on the document, Paul, thank you for being my sharer there. But really, I think I tried to distill this into sort of three things when zooming back out. So I think in this domain, they want you to know about the Palo Alto product families. They want you to know about Strata, Firewall, Prisma, and Cortex. And I would say a lot of elements under here, you're going to learn down the road if it's on the Strata side. You could go deeper on Cortex or Prisma, but it's not going to benefit you on the pursuit of this certification. It's more about just understanding the product family there. I think they dabble into some features in the Strata domain in the next generation firewall. And I think what they're getting at is, can you tell me about it? Can you tell me what it does? And it's at high level. A lot of those are going to be a deeper dive going forward. And that was really it. So again, know the product families, thinking of answering what is X, describe what it works and what it is and how it works from a high level. And then going deep, you're going to run into the firewall stuff in the following chapters. If you go deep in Cortex and Prisma, it'll be fun, but it won't be relevant to the PCNSE beyond domain 1. I'll leave it at that. This was actually really good. I really enjoyed the well-rounded view. Thank you guys for all the distillation summary, and look forward to seeing everyone on domain 2. Thanks, everyone.
Great. Thanks.
Have a great Friday.